Hello everyone, welcome back to my channel. Today we'll be solving Leetcode problem 2401 longest nice subarray. Okay. The problem statement states we have been given an integer array nums which will contain all the positive numbers, and also they have defined a property called nice. Okay. What does nice means? A subarray is called nice if it contains a bitwise AND of every pair of elements that are in different position in the subarray is 0. Okay, the bitwise operator, let's say if we have picked a subarray 3 8 10. Okay, there are three pairs which are possible: 3 8 3 48 8 48. Bitwise operator of all these pairs is actually 0. Okay, we have to return the length of the longest nice subarray. Okay, subarray, they have defined a subarray as a continuous part of an array. It should not be breaking, like you cannot take 3 48 and 10. It should be continuous, like 3 8 48 1 3 8 or 1 3 48 or 1 3 10. Okay, and note that the subarray of length 1 are always considered as nice. Okay, and an element with 1 is always considered, a subarray with single element is always considered as a nice. Okay, standalone 3 is considered as nice. Standalone 48, which is a subarray of length 1, which is also considered as nice. Okay, so let's jump back to uh, the editor. Okay, and notepad, and let's see few things over there. Okay, so here we have been given, as you can see, this is the example, like 1 3 8 48 and 10, right? Uh, this is the array example, right? And we have n as the length of an array, and n square is basically, if you can see, if this is an array of length n, we can actually form n square subarrays, right? So like we can form 1 3 1 3 8 1 3 48 1 3 48 and 10. That is, like, in such way we can form so many subarrays. Okay, so actually let me note it down and let me explain you, and it will be a lot more clear then. So we have 1 3 8 48 and 10. Okay, so how many subarrays can be formed here? Okay, like we can form 1 standalone is a subarray, 1 3 is a subarray, 1 3 8 is a subarray, 1 3 48, 1 3 10, and 3 alone is a subarray, 3 8 is a subarray. Like for every element I can include all such subarray, the remaining elements in the subarray. So initially I can form n subarrays with this, and I can form n subarrays with 1 as a starting element. I can form n minus 1 subarrays with 3 as a starting element, n minus 2, and so on up to 1. Okay, so if you count total number of subarrays, it will be n into n plus 1 divided by 2. That means we can total form order of n square subarrays. Okay, so order of n square subarrays can be formed. For all those subarrays, we have to identify the, for each subarray, right, we have to check every pair, and then if the bitwise operator, bitwise AND of all the pairs, if it is 0, then we should include that as part of our solution. Okay, so the problem statement says bitwise AND of every pair should be 0. Okay, so if bitwise AND of two numbers, if it is 0, that means we can see a behavior. Okay, if that means both the numbers should have different bits set. Okay, different number of different set bits. Okay, so let's take an example. Let's take 6 as x. Yeah, 6 has basically these bits set. Let's take 1, which is basically 0 0 and 1. Okay, if we do bitwise AND of these two numbers, it will be 0 0 0. As you know, bitwise, what does bitwise AND says? If both the bits were set, then it will resultant bit be set. If in all other cases, it will be unset. Okay, bitwise OR basically says if both the bits, if any one of the bit is set, then the resultant bit will be set. Right? If both were unset, then it won't be. The resultant will be unset. Okay, what does bitwise OR operator says? If both the bits were set oppositely, then the resultant will be set. If both the bits were set same, then the resultant will be 0. Okay, so this is what bitwise XOR will look like. Okay, so you understood here, right? The bitwise AND of every pair should be 0, and that means if bitwise AND of two numbers, if it is 0, that means both the numbers have different bit set. Okay, if there are any bits which are overlapping, let's take another example as 6 and 4. Okay, if you take 6, this is 6 and this is 4. Okay, if you do bitwise AND of these two numbers, then you will get both. If both is 1, then it is 1, 1 0 is 0, 0 is 0 0. Okay, so the resultant is actually greater than 0. Okay, this bitwise AND of 6 and 4 is actually greater than 0. That means there are, if there are any overlapping bits, okay, then the resultant will be greater than 0. Okay, so x and y, if it is greater than 0, this implies there are overlapping bits. Okay, so just note, keep this property handy. Okay, this will be useful. Okay, and let's do bitwise OR. Okay, bitwise OR of two numbers. Okay, let's take x or y. Let's take x as 5, which is basically this. Let's take 3 is basically 0 1 1. Okay, if you do bitwise OR of these two numbers, okay, wherever there are if the bits were set oppositely, if any one of the bit is set, right, that means the resultant bit will be set. Okay, so here 1 0 is 1, 0 1 is 1, 1 1 is 1, right? If you observe, whenever we are doing OR operator, right, all the bits which were set, they were preserved from 5, and bits which were also set in 3 were also preserved. Okay, so this is another property which we can notice. Okay, bitwise OR of two numbers will basically preserve the set bits from two numbers, right? This is one property you have seen. Okay, if in XOR, if the XOR of two same number, okay, let's come to XOR later. Okay, now the idea here is, if you see the bitwise AND of two numbers, if it is 0, that means there are no overlapping bits. Okay, that means there should not be if it is 0, that means no overlapping. If it is greater than 0, that means we have overlapping. Okay, so the question says that we have to identify a subarray, right, where the bitwise AND of all possible pairs is actually 0. That means all the bits which were set in all the numbers are actually different. Okay, the bits which were set in number 3 will not be set in 8 and will not be set in 48, and vice versa. Okay, so all the bits which were set in these three numbers will be unique. Okay, so if I have to make a decision that 10, can I include 10 in my solution, like in the subarray or not, how can I identify that? I can only include 10 in my solution if it has bits which were not set as part of these elements in the subarray. So how can I identify the bits which were set in all these three numbers? Okay, that means I have to preserve the bits from 3, I have to preserve the bits from 8, I have to preserve the bits from 48 as well. That means we have to do bitwise OR operator. Okay, so I can do bitwise OR operator of all these three numbers. Okay, so bitwise of 3, 8, 48, this will tell me what all bits this will tell me the set bits of all set bits present in these three numbers, right? And now I know a number which has bits which are set in all these three numbers. Right now I have to check whether 10 can be included or not. I can only include 10 if it does not have overlapping bits from these three numbers, right? So how can I identify whether 10 does not have overlapping bits or not? So I can simply do, here we have a property, so if we can do AND with 10, and if it if it turns out to be 0, that means it is non-overlapping, right? If it is turns out to be 0, then it is non-overlapping, right? Okay, let me write it down. I think it's becoming a little clumsy over here. Let's go down. Okay, let me write it down here. We have 1, 3, 8, 48 and 10. Okay, so if I have to include 10 in the solution, so I already know what all set bits of these three numbers, right? Which is basically the OR of all these three numbers. Now if I have to include 10 in my subarray, then I can only include 10 if 10 does not have any overlapping bits. That means I know if bitwise AND of set bits and 10, if it is 0, that means there are no overlapping, right? Then only I can include it. If it turns out to be greater than 0, that means there were some overlapping bits. That means I cannot include. Okay, that means there were some bits which are common between it can be common between 3 and 10, it can be common between 8 and 10, it can be common between 48 and 10. We don't know exactly like which bits are coming from. Okay, let's say we have, let's rename that as some a1, a2 and a3, and we have 10. Okay, we don't know exactly the bits from a1 are corresponding to this overlapping or a2 or a3, we don't know, right? So we have to remove each number and we have to check whether still there are overlapping numbers or not, right? So how can I remove the set initially the set bit contains all the bits from 3, 8 and 48, right? So if I have to remove the set bits, that means bits which were part of 3, that means I can do XOR. Okay, if the bits were set, right, if I do set bit with set bit, that means it will turn out to be 0 if I do XOR, right? So all I have to do, if I have to remove the bits of a1, then I have to do XOR with a1, that's all, right? If I do so, so I can simply do XOR with a1. This will remove the set bits, right? Set bits of a1. Then again I have to check whether I can include 10 or not, right? So now the set bits will only contain the bits from a2 and a3. Now I can check whether 10 can be included in the solution or not. So when can I include 10 in the solution? If the set bits and 10, if it is equal to 0, that means there is no overlapping, right? Again I can include this solution. I have to repeat this process, like every time I have to include an element and I have to check whether are there any overlapping or not, right? So I have to keep on repeat this process until and unless I reach till the particular element, until and unless I exclude all the elements and I reach till the corresponding element. Okay, once I identify there are no overlapping, I have to keep on removing the elements from the start of the window. Okay, so yeah, so the thought process is basically we'll have a pointer I think by now you might have already figured it out. So we'll have a pointer called start or left. Okay, and we'll also have a pointer called end, which will basically tell us the start and end of the subarray. Okay, so initially now I have to make a decision. Initially like we will be having a subarray of length 0, like there are no elements. Now I have to make a decision whether I can include one in my subarray or not. How can I include one in my subarray? Like if there are no elements, I can simply say the set bits of, or I can simply say the set bits as 0. That means there are no elements, that means there are no set bits. Now I have to make a decision whether one can be included in the subarray or not. That means I have to check are there any overlapping bits. So I will do 0 and 1. 0 and 1 is actually 0. That means there are no overlapping there are no overlapping bits, that means I will be including 1 in my solution. So my subarray will look something like this, will have 1 in my solution. Now since I have included the current element in the solution, now I have to update my uh, answer, which is the length of the nice. Initially the length would be 0, now the length would be end minus start plus 1. Here end is basically 0 and start is also 0 and 1, which is actually 1. Okay, so now I have included the set bits, right? I should include once I understood that there are no overlapping and I have updated the length, I should include 1 in my window. That means I have to include when I am including my 1 in my window, that means I have to do OR. Okay, 0 or 1. Now my end I will increment my end. Now I will again check whether 3 can be included in the solution or not, in the subarray or not, right? So in order to check 3 can be included in the subarray or not, now the set bits is actually 1. So 1 and 3, right? Whether this actually this is greater than 0, that means I cannot include 3 in the 3 in my non-overlapping the nice array. That means I have to remove the bits which were common between 3 and which were already part of the existing subarray. So I will remove the elements from the start and I will keep on check whether I can include the current element in the subarray or not. Okay, so that is the thought process. Okay, let's try to code it down. Okay, so yeah, I'm back to my Leetcode. Okay, so as I mentioned, I need 2 pointers. One is start, which is 0, and one is end, which will tell me the window size, and the length is basically the length of the array, and we'll have something called max length, which will tell me the length of the nice subarray, right? Now as I mentioned, I have to every time I have to make a decision whether I should include the current number. Okay, I have to make a decision whether I have to include current number in the existing subarray or not. So initially the existing subarray set bits would be initially the length would be 0, that means there are no set bits. So let's say the set bits, initially there are no set bits. Right now I will start from while end is less than the length. Okay, now I have to make a decision whether the current number can be included in the existing subset or not, right? I can only include the current number in the existing subset when there are no overlapping. First I have to check whether are there any overlapping or not, right? So in order to check overlapping, I have to do set bits. If there are overlapping, that means set bits and the current number. If it is greater than 0, that means there are overlapping, right? So set bits and the nums of end, current number, which is the end number. If it is greater than 0, that means it's an overlapping. That means there are some overlapping bits. I have to remove all the overlapping bits. How will I remove the overlapping bits? I have to remove from the start and keep on check whether I have removed all the overlapping bits or not. So in order to remove the bits, as I mentioned, I have to do the bitwise XOR operator, right? So set bits XOR of nums of start. Okay, and once I remove the set bits, I should also update my window, which is start plus plus. Now this loop will continue until and unless all the bits were unset. The moment all the bits were unset, that means all the overlapping bits of the current number were removed. Okay, that means this number is good enough to include in the result subarray. That means I have to update when I'm including this number in my result, that means I should also update the set bits, right? So So set bits is a nums of n. So now I have included nums in my resultant subarray. I should also update my answer, right? So the max length, since I've included nums in my subarray, so there is a possibility that we might have identified a bigger subarray, right? So I should potentially update my subarray, the length which is max length, which is end minus start plus 1. Okay, now that we have updated our length, okay, so that means we have included this number in the solution, so we have to make a decision for the next number. So that means we have to increment the end as well. In the end we can return the max length. Okay, let's try to submit this. Yeah, it has passed the basic test cases. Let's try to submit the solution. It has also satisfied all the test cases. Okay, so here the overall time complexity is actually the linear time, because we are actually traversing the entire array in a single iteration, and then we are identifying the solution. Okay, even though it looks like two while loops, but we will be encountering all the numbers only once, or max twice, okay, in this case, because not more than that. Okay, so that's all about this problem statement. Yeah, do subscribe to my channel for more such coding videos. I will be posting every day one coding problem. Yeah, thank you.